let's dive into some of the astronomy here. Let me pull up again. Let me grab my share screen here. Here's your coordinate systems. Okay, so you've got basically four systems. So the horizon or altitude azimuth system. And this is the thing that would be most closest to an observer on the ground. Like if you walk out at night and look at the night sky, or if you were, somebody 4,000 years ago looking at the night sky. The reference plane is just simply the local horizon. It's measured by altitude above the horizon or below. And the azimuth is going to be the direction clockwise from due north. And it's used for, as it says, celestial observation relative to a local reference point. Okay, then as you move out from that, you come to the ecliptic. The ecliptic, which is Earth's orbital plane, is measured by ecliptic longitude and ecliptic latitude in degrees. And this is primarily used for describing the motion of planets, comets, asteroids, etc. But I think right there might be a clue, describing the motion of planets, comets, asteroids. Equatorial, celestial equator, measured by your right ascension in hours, minutes, and seconds, declination in degrees, above or below the celestial equator, used primarily for star atlases, objects fixed in the celestial sphere, which of course is your fixed background, which is your reference against which all of this motion is going to be measured. And then finally, you have the galactic system, which is based upon the Milky Way galaxy. The galaxy has its own plane, axial plane. So it gives you galactic longitude and galactic latitude in degrees. This is going to be primarily for objects outside the solar system, stars, star clusters, galaxies, etc., used by modern astronomers, presumably not by ancient peoples, who are going to be presumably not going to be looking at objects outside the solar system. However, when we get to the various alignments, then these various systems with their reference planes become more relevant. A more elaborate description of these: horizon system, azimuth is measured in degrees clockwise along the horizon from geographic north. Altitude is measured in degrees above or below the horizon. It locates a position in the sky relative to a specific time and position on the Earth. Altitude, azimuth coordinates change with any change in time or location. The coordinate system, which is most useful for archaeology. Okay, then you have your ecliptic system, which gives you ecliptic longitude, which is measured eastward along the ecliptic plane, from the vernal equinox. Okay, now this is the thing that's moving. It's this vernal equinox that's moving. And so the vernal equinox moves, the autumn equinox is moving, the solstices, they're all moving together. You got to picture that big cosmic cross is rotating, right? Ecliptic latitude is measured north or south from the ecliptic plane at 0 degrees to the north or south ecliptic pole at 90 degrees. It's used to specify the locations of objects orbiting the sun, referenced to Earth's orbital plane, considered the natural coordinates for the solar system. Then you have the equatorial system, which is right ascension and declination, corresponds to terrestrial longitude and latitude. So imagine Earth's latitude and longitude lines projected into the celestial sphere, and that gives you your equatorial system, right? And the 0 point, reference point, would be the celestial equator. Right? Right ascension is measured in hours, minutes, and seconds with a full circle of 360 degrees equaling 24 hours. Well, that's because the whole thing is rotating. And we've designated that period one tropical day from a point on the Earth coming around and then coming back to the same position relative to the sun is what we define as a tropical day of 24 hours. We take that period, we divide it into 24 hours. Right? Which, as you commented earlier, Kyle, whoever you are, you said earlier about that difference, right? Because what's happened is it comes back around, but the Earth has moved a little bit in the interim, right? And so has the sun. And so it takes a little bit longer for that point to catch up to the sun, which has been moving eastward during that passage of time. So your tropical day, which is measured one rotation relative to the sun, is a little bit different than the sidereal day, which is measured with respect to the fixed backdrop of the stars.
Right.
Right. So the 0 point of right ascension is the vernal equinox.
Okay.
Equatorial system is aligned with Earth's axis of rotation, but does not rotate, causing the stars specified by the system to remain fixed over the course of a day, used most commonly to specify fixed celestial objects, such as various stars or distant galaxies, or, anything that's basically going to be fixed within that, unlike the planets or the moon, comets or asteroids or anything like that. And then finally, the galactic system, which is galactic longitude is measured in degrees from the galactic center in Sagittarius westward along the galactic equator. Galactic latitude is measured north and south from the galactic equator to the north and south galactic poles at plus minus 90 degrees, used primarily for dynamical studies of the macro scale universe. Okay, so with those planes in mind, let me see if I've got some graphics here to help visualize. Okay, so here's this yellow line is the plane of the ecliptic, and this is the celestial equator. And you can see in this particular configuration, the plane of the ecliptic is shown as a vertical line, and the celestial equator, you can see, has this bit of a curve to it. And the reason for that is because if you extended this off the slide, the celestial equator and the plane of the ecliptic, they intersect, right? And it's those intersection points that are the equinoxes. Well, this is the solstice, and the solstice occurs when there's the maximum distance between those two planes. And you can see here that it's right here at this 18-hour line, right? So this line, check this out, this line, the plane of the ecliptic, and then this green line is the galactic plane, right? Now you'll notice this intersection of those three lines right here. The 18-hour line is relative to the solstice line, right? This is December 21st. I actually did this back in 2012 to try to show people what the astronomical significance of that particular day was. It shifted a little bit since then. I think by about maybe 7.5 minutes, maybe, of arc in the 9 years since then. But this is high noon at 23.5 degrees south latitude by 45 degrees, 26 minutes west longitude. And what you're seeing here is this alignment. Notice the ecliptic plane, the 18-hour line, the solstitial line, and the galactic plane all intersect in this point right here, right? Now I'm going to jump here to the winter solstice, because this is winter solstice. This is winter solstice of 2012. Now, from our point of view, I'm just using Fort Ancient as an example. We can see that. Let's see here. There we go. There we go. Okay, so that event that's happening now in this epoch, and was pretty much very precise on 2012. We'll see right here. So that's what's going on. So the thing that I want you to try to grasp here is that if you're standing at the center of this and you're looking out through this notch, you've got one line that's leading from the observer here through the center of the sun right into almost basically the center of the galaxy. Now that's pretty cool. You got an alignment between the galactic center, the sun, and the earth. That's what's happening. And that was pretty much the astronomical significance of what happened on that day. Now, like I said, it's shifted, I think, about 7.5 minutes of arc. So it's a little bit moved, because 50 seconds of arc per year. We've got 9 years since then. So 9 times 50 is 450. Divide that by 60. Yeah, 7.5 minutes of arc. So in other words, that position there has moved in the 9 years since 2012, the distance roughly equal to 1/4 of the way across the disk of the full moon.
Now, that's how much it's precession.
That's due to precession. That's exactly right. That is due to precession.
Yeah.
So basically, what you're seeing right here, it happened. Now it's deviated by 1/4 the distance across the full moon, and in 25,920 years, it will come full circle and be back here to this alignment again. So that's kind of cool. So now if you're going to, it occurs to me that, if you're going to define a great year, one of the obvious questions is, well, where's the beginning of the great year? Do you have some point that you can say, okay, this is the beginning of it? Does it coincide with 0 degrees Aries, which is, not the great year, it's the tropical year, right? And the sign of Aries is moving along with, because as this precession is going along, it's dragging the 12 signs with it, because the sign of Aries is hinged to or attached to the spring equinox, and the spring equinox is moving, but the constellations aren't. So there's like 2,500 years roughly of motion now that has offset what was originally the sign. If you could go back in a time machine roughly 2,500 years, the vernal equinox is positioned in such a way that, it's between Pisces and Aries. And so now the sign of Aries coincides with the constellation of Aries, but the constellation has remained fixed and the sign has been moving at the same rate as precession. And so that's why now the signs and the constellations don't line up anymore. And they won't line up again for about another, 24,000 years.
But is that just because people is that based on astrology, like the astrological signs? Because
no,
if anybody's doing,
that's totally astronomical. Now, see, so that's the difference between tropical. Now, I'm not an astrologer, but that is the difference between tropical astrology and sidereal astrology. Sidereal astrology is going to look at the actual stars,
right, yeah.
Whereas tropical astrology is going to look at the signs. So, if you're born under a certain sign, that's not necessarily, the sign that's on the horizon, say, for example, isn't going to necessarily be, it's not going to be the same as the constellation. They're going to be offset by, as much as, well, about 15 degrees or more. Actually, more like 30 degrees.
Yeah, we're it depends on when the signs were first set.
Yes. Right. And so again, that gets back to what I was saying about, where's the exact starting point? Now, from my perspective, you've got to have something that is going to remain fixed over a long period of time. And these rotating solstices and equinoxes every 6,400, now in 6,480 years from now, this is going to be the position of spring equinox. And it seems to me that if I was trying to set out some point of demarcation for the great year, the spring equinox lining with the galactic center might work pretty good for that.
Yeah.
So here's a little bit closer look at that whole alignment. I've now rotated it 90 degrees, and I've put in the traditional depiction of Sagittarius and Scorpio. So here now you see the galactic center. Now I think that there's a little bit of variation in where exactly the galactic center could be, but you see that from the standpoint of us, it's actually, I'm zoomed in here, so it's actually very, very close to this alignment right here. So here's the galactic plane. It would be the local meridian at this moment that defines this 18-hour line right here, which is the maximum difference between the celestial equator and the plane of the ecliptic. And so you can see that all of these lines are converging right here, very, very close, interestingly, to the traditional depiction of Sagittarius, with a little bit of, and I've looked at various traditional depictions, and they're not all exactly the same. There's some variation. And then you can see, though, how closely the point of the arrow of Sagittarius's bow and arrow conforms to that unique point right there, which is the center of the galaxy. The arrow, of course, is pointed right at Scorpio, right over here. So I thought that's interesting. It's almost as if, I bet you, I could even propose a hypothesis that we find some ancient depiction of a traditional Sagittarius where the point of the arrow is aimed directly at the galactic center. The whole phenomena to me is just extraordinarily fascinating. And I bet you Dave Mathisen would probably have something to say about this.
Yeah, I certainly thought that earlier.
Oh yeah, he would for sure.
Yeah. For people who don't know who he is, Ross, why don't you just
Well, let's get him on one of these soon.
Yeah, we need to get him on one. He would love to do. He would love
Sure.
to here and talk astronomy and ancient mythology with us in connection to the constellations and the stars, which is what he does. So Mathisen has done a ton of research and drawn a lot of excellent, interesting, possible connections between global mythological stories and constellations, and he shows how over and over and over the depictions of certain, whether it's a well-known myth or a very obscure one, the depictions and the descriptions match constellation imagery over and over and over. So
over and over and over. Yeah.
What exactly that means, Kyle and I are always asking him, well, what does it mean, Dave? And he's like, I don't know, guys. I'm just.
There's many heroes and gods that are positioned like Hercules or
That's
particular constellations.
It's, even you can even use like monomyth or the hero with 1,000 faces, that kind of stuff. Like,
and he's got quite a few books, and some of them are great big ones. So he put a lot of research into it. And well, I'll say what my guess is, but then Randall did kind of hint at it that there were possibly
go ahead for
orbits of other things coming around that would be on a longer time scale. So that's what I was going to prognosticate. Maybe if that's an annual marker, right? And then that helps them track things like, then they got larger cycles like out at Chimney Rock, right? They're tracking the 18.3 or 18.6 year moon cycle, right? So then maybe there's got to be larger cycles that if there's some deviation off of that annual
we're talking about precession of the Earth. We're talking about the rotation of the solar system. The solar system rotates within the galaxy. The galaxy rotates. We're talking about
bigger cycles.
Cycles upon cycles upon cycles. It's almost metaphysical there.
Since you mentioned Chimney Rock, go ahead and pull up.
Mathisen's website is starmythworld.com.
That's right.
There we go. Starmyth World.
Close. Yeah, thanks.
Yeah, I think it would be great to get him on here for a visit.
We could definitely do that.
Yeah, and I bet he would. Yeah, so here's Chimney Rock. We've made several excursions up this ridge and to see this firsthand, and we're going to try to get back there for 2023 when the alignments come back around again. But let's see here. Yes, so this is, you've got your Chimney Rock Observatory Complex right here, and here's the two pinnacle rocks, and these ancient Chacoan people were utilizing this as an observatory to monitor these celestial motions, as we'll see here. Let's see. So this was the fire tower that's no longer here. But interesting, this fire tower was built right over the remains of an ancient signal tower that the Chacoan people used to build huge bonfires up here that could be seen from, many, many miles away, and was part of a whole complex that we're going to talk about when we get into doing a session about the Chacoan culture. We'll look at some of this in more detail. So that'll be coming up at some point. But this was one of the signal towers was here that was part of this whole signal system, using great bonfires, presumably communicate on some level, over the full 10,000 square miles of the layout, the infrastructure of. So here's looking back at the ruins of the observatory. This is looking one direction, and when you turn around and look the other direction. And one of the things that was interesting was this ridge, because apparently there were structures along this ridge that marked these positions through the course of the year. So here's your the sun rising between the two pillars. And let's see, we're not going to get into this too much. We'll save this for discussions about the moon, other than the fact that the moon, you can see here that the moon's orbital plane is angled from the Earth's orbital plane by 5.145 degrees. That little tilt of the Earth's, see, if these two were in the same plane, then we would have eclipses every month.
Yeah.
We would have solar eclipses and lunar eclipses every month, but it's only, again, it's the intersection of those two planes, and the moon has to be, the closer the moon is to that exact point right there, the intersection is the more complete, you know, the eclipse is going to be. So here you've got, see that major standstill of the moon path. So rising right there between the two pillars. And this is from the vantage point of the observatory. Summer solstice sun path, minor standstill moon path. And here's the whole calendar laid out on the horizon. And it's quite a spectacular feat that they came up with. And you see summer solstice sunrise path, winter solstice sunrise path, and then equinox sunrise path. So here you can really get a sense of how, from this observer up on this ridge, using the pillars, rock pillars as a, you know, as a reference standard, you could watch this motion and see. So here's the yellow circles is the sun. So it's going to be swinging back and forth. So from here, summer solstice swinging to the south for 6 months. For 3 months, then another to here. Then it makes this return, comes back, and it does this back and forth phenomena. And then juxtaposed on that, you've got the moon paths, you see. And what's interesting about that is that the moon actually oscillates in such a way that it has two minimum and two maximum. So you can picture, if you figure minimum like this, and then maximum like this. So it swings back like this. It'll do the minimum rising and setting, and then it'll do the maximum rising and setting. And that cycle is 18.6 years, and it's that cycle that's coming around in 2023. So yeah, so here you can see, yeah, the sun is setting, and you see so on the equinox, the shadow will pretty much point due east. Okay, we don't need to get into the
other interesting feature of that in that picture right there, well, the overhead, the wall, that flat wall of the structure they built is lined up with the Crab Nebula.
Yeah.
This wall right here.
Yeah.
Yeah, we learned that, didn't we, when we were there?
Like they witnessed that event.
Yeah, the whole thing. And, we're just, it's a challenge to try to really understand what was going on there. But, we have these tools at our disposal now that should be theoretically helping us figure all this stuff out, because, we've got, hey, just the tool of the astronomy software that I've got. Anyways, briefly, well, since we've got, solstice there, and we found out was 9 o'clock something tomorrow morning, coming up in about 8 or 9 hours. And that will be when the sun reaches that maximum southerly position on the horizon. And we've talked about how it sort of stalls there for a few days. And so the ancient ritual of the returning of the light was that every day, the day is getting shorter, darker. The sun seems to be moving further away. Temperatures getting, beginning to decline. We see nature go into decline. Then it gets to the solstice and it hangs there for a while. And then typically 3 to 4 days later, it's obvious now that it's begun its return journey. So you can actually see now that the Christmas celebration is tied to the solstice. And it's not exactly on the solstice, because it really is commemorating that morning or that day that the return of the sun, the return of the light has become obvious. So that's something to think about on Christmas, is that there is an astronomical correlation to it.
Yeah.
And by 4 days after the solstice, you go out there in the morning and go, yes, the sun, and you're monitoring it on that horizon calendar, right? So now 4 days later, you go out and you're seeing, hey, the sun has moved.
Yeah, it's been born.
It's been born. It's returning. And this is that myth of the return, right? The return of the sun, right? S-U-N, but also the return of the sun. So it's really right there is sort of the whole astronomical basis of the Christian mythology, which is basically just a repackaging in its own way of the pagan mythology. Brad, you were mentioning earlier about Mithras and many of the other gods that died and were resurrected. But in this case, it's correlated to the sun myth, which is, again, interesting to me. And that's certainly something to dive into further when we get into the some of the Grail mythology will be coming back to some of those ideas, and the idea of the esoteric dimensions of Christianity that have sort of been obscured over the years.